Thank you. Everybody can hear me pretty well? Good? Cool. Thank you for your patience while I was setting up the things, and thanks a lot for waking up so early to come listen to us pitching to you. I'm Lucas Vandroux. I'm the founder and the lead machine learning engineer and computer vision scientist at VIUN Engineering. And unfortunately for you this morning, I'm not the last pitch, so there will be one more after me between you and the breakfast buffet. So I don't want to waste any of your time, so I'm going to go straight to the point. My objective today is to convince you that you should have already started to capture images about every visual inspection process that you have in your factory. So maybe to start a bit, let's kind of define what is visual quality inspection. It's like every visual check that you're doing on a part, either with like some microscope or also with actually naked eyes. The interesting part of this is like it's all over the production and the quality inspection process. And most of the time, it's actually the first thing customers are going to look at. They're going to receive your product. What are they going to do? They're going to look at it, even if it has nothing to do actually with the use of the product itself. So problem is, compared to dimensions or maybe functional testing, visual quality is not measurable or hardly measurable. So most of the time, it relies on the experience of humans in order to actually judge what's the quality of what they see. It can take maybe from a couple of days to actually a couple of years to train someone to be able to recognize good and bad quality on certain products. So maybe I'm going to give you a bit of examples. Sorry about the quality for the images, but let's start here, okay? This is like images from one of our customers. Some boxes that are made with plastic injection molding. I'm just going to go with the letters, and I want you to raise your hand if you think this picture contains a defect. Are you ready for it? Okay. Who thinks, hey, the picture A contains a defect? Good. B? C? D? E? F? G? And H? Okay, well, I see I'm with professionals today. So yeah, let's increase the difficulty a little bit more. So those are like images actually from one of the Swiss Mark factory partners. We're doing a project with them at the moment, Rollomatic, and they're building machines to build cutting tools, if I may summarize what they're doing. Here we're looking at the cutting edge of the tools that are coming out of their machines. On the left here, you have like a good part, and here you have actually 8 samples from their calibration process. 3 of them contain a defect. So I want to do the same thing with you. Who thinks picture A is contain a defect? Picture B? Picture C? Picture D? Picture E? Picture F? Picture G, and picture H. Well, I think a lot of very divergent opinion on this. I think some people even say there were more than 3 pictures with defects. But actually, those are the ones with defects. A bit more difficult in that case. And to be frankly honest, and maybe to reassure you, even for Rollomatic's experts, that for some have more than 10 years experience inspecting those parts, it actually can also be extremely tricky to recognize if those are like good or bad parts if they just look at the picture. So we actually pushed this to the points that we took images from their calibration process, actually 100 of them, and we asked 4 of their best operators, please tell us if what you see on the picture is a good picture or is a bad picture, or like, is there a defect or not on this cutting edge. And here you see the number and the repartition actually of their judgment. So OKs were like, okay, the part was good. DKs were don't know, so the operator didn't know, or maybe needed some advices or like some other to talk to a colleague. NG is not good, so for sure the part was not good. And after we have mix where maybe some operators say it was okay, some operator didn't know, or at the end, actually some operators say it was okay, some operator didn't know, and some operators said that it was actually not a good part. And that's actually the very interesting part. We see that most of the distribution is actually on the right. 50%, more than 50% people are a little bit indecisive, and more than 10% actually, an operator is going to say, this is a good part, and another one is going to say, this is a bad part. So, yeah, visual quality inspection is done by human, right? I think we're all human, so we know this. We are extremely easily influenced by external factors, and therefore visual quality inspection is very hard to standardize. And it can actually be extremely costly. First in terms of money, but also in terms of reputation. And I think for Swiss companies that are world-renowned for their high quality, this can be actually very problematic to ship a bad quality product. So functional testing, dimensions, we have tools, straightforward to test them. But the question is, like, actually, can we test visual quality in such an easy way as well, and a reliable way? And the good point about this is actually, yes, we can. And the funny joke about this is that people learn how to recognize quality, but nowadays machine can learn. So I don't know if you heard about something called machine learning, but that's the same principle. So for the specific case I showed you just before, 100 images, those operators have looked at them, they gave their judgment, and then our system actually used it to learn also what was the quality of the parts. And the interesting thing is that actually for a third of all the parts that were shown afterwards to the system could confidentially say, hey, this is a bad part, hey, this is a good part, and I'm sure about this. And for the two-thirds that stayed, the system had an opinion, but preferred to actually ask for help and say, hey, maybe it's bad, but I'm not sure, I would like someone to review it. And the good thing about this as well is that 0 parts that were good were confidently labeled as bad, and inversely. So the system was really helping the people to either make the inspection faster, in the sense that those experts don't need to actually come and check on the parts, because the system can already say with confidence for a third of them, hey, this is good or this is bad. And for the rest, they could actually receive just a message on their computer saying, hey, can you check if this is good or if this is bad? No need to move, just to look at it and help the machine to learn. So the question nowadays is actually not if machine learning can work actually in manufacturing. Machine learning is working. The problem is, or the question is, how can we make machine learning works in a cost-efficient way and something that is actually customized to the process specific for every manufacturer? And this is where actually we developed the product specifically for this. So we have a platform that fully integrates in the process that already exists, that integrates on the cameras on the machines, capture images, and also captures the information and the knowledge from the operators in order for the machine to learn what are the qualities. This is very useful if you want to actually digitalize the visual quality inspection process that you have, but also to standardize it and to help actually the collaboration between the different quality stakeholders. At the end, it's way more flexible than a traditional computer vision or actually a visual inspection system, as you're the one actually teaching the system what it should look at. And you don't need actually to have specific engineers that are going to look at what are the parts, what are the problems, and actually build a very customized system to only solve a part of the visual inspection of audio factory. So that's all for me. If you're interested in what we're doing, you can actually follow us on LinkedIn. That's what the QR code here will give you. And if I convinced you that you should have already started capturing images on your visual inspection processes, then actually I'm waiting for you there with the 2 screens at the tables to show you more about it. So otherwise, I think we still have 2 or 3 minutes for question. Thank you very much.
Yes, thank you very much. Questions from the audience? Okay, go first and then continue.
Okay, thank you for your presentation. It was very good. And my question is, so your company's product is software, or also you're providing like whole hardware together, like big machine?
Good question. We are only providing the software, but as it's manufacturing and sometimes you need integration, we either work with integrators or bring some off-the-shelf hardware to integrate in cameras or different machines that are already available.
Main domain is like software.
Domain is like software, exactly, yes.
Like you mentioned that you could recognize 1/3 of the images perfectly. And did you improve this over time, or was this even the goal to improve?
Oh, so yeah. Thank you for asking. I forgot to mention it, but yeah, the goal is that the system continue to learn every time someone is actually giving an input on a new picture. Here, as I told you, the proof of concept is still in progress. So we are waiting for the next phase to be able to tell you the new accuracy of the system.
Okay, very good. Some other questions? Okay, maybe Luca also regarding to the integration of your solution. How's the process going when you integrate your solution from bioengineering in a traditional vision process?
I mean, as I said, we are mainly building the software. I mean, I think we see it on the picture here on the right. So this is just they have already their whole process. They use a Keyence actually camera or microscope to inspect it, and they just take the picture with the Keyence software, and this is automatically imported in the software in our platform, where they can just say, hey, this is the quality of the pictures that I've seen. And if it's not a manual process, then and the factory has actually an integrator team, we can actually discuss with them to integrate it further in their machine or in their process. Thank you.